All right, so thank you very much. So I'm Justin Tiehen. This talk is on AI zombies, and it's going to draw especially on two empirical approaches to mind. One is the global workspace theory, also a little bit about that, and the other is resource rational analysis. And I want to mention this paper, the sort of paper that we're working on. It's co-written with Ariella Tubert, who's also a philosophy professor at University of Puget Sound, and my wife. She's a moral philosopher, works on practical reason, and so the moral implications, sort of especially sort of coming from her, and then I'm a philosopher of mind, interested in consciousness and other topics, and so that's she couldn't make it, but I'm here, so I'll present. And let me give you sort of a way, I think, a question to sort of orient you to the entire talk and sort of a slogan form eventually of what the view I'm going to be somewhat tentatively defending, but I'll sort of drop the tentativeness and just sort of present it as sort of all out. And the question is, what exactly is the relationship between consciousness and intelligence? So if you, one way you can imagine is like mapping it like on an XY diagram, and on X, it's like you're getting more and more intelligent among all nomologically possible beings. And the other side, the Y side, is either degrees of consciousness, or if you think consciousness is all or nothing, it could just be, do you have consciousness or you not? And one possibility is just that there are two independent features of the mind. Intelligence is one thing, consciousness is another. Another possible view is that there's going to be a kind of positive correlation between intelligence and consciousness, and that can work out different ways. One could be maybe there's certain kinds of intellectual abilities you can only achieve or most easily achieve by being conscious, and so those beings who lack consciousness either are entirely excluded or unlikely to have those forms of intelligence, like maybe, who knows, maybe theory of mind you need consciousness for. Or it could be not specific to some, not keyed into some specific ability, but it could be general. So maybe consciousness goes with forms of learning, and across the board, you're going to be sort of missing out on intelligence, forms of intelligence, if you don't have consciousness, at least in general. And then here is a third view, which I think has been sort of, it's, I think, more counterintuitive, kind of underexplored. This is going to be the view that I'm tentatively defending, is that there's going to be a kind of negative correlation. And so sort of in slogan form, here's what the view says. It's that intelligence is the enemy of consciousness. So that for beings like us, we happen to be both intelligent and conscious. If you can imagine sort of in that sort of map of beings who have at least human-like intelligence or greater, maybe superhuman, super intelligence, in general, those beings will not be conscious. And the smarter you get, the more intelligent you get, consciousness will sort of dim out and be sort of annihilated. So if you're sort of imagining it, is that then in general, the map of artificial general intelligence, at least our level or superhuman level, it's going to be a kind of map of zombie country. In general, these beings are going to lack phenomenal consciousness, so they're going to be something like zombies in the philosopher's sense. And so again, I just sort of want to be clear, that's where the view is going to, where I'm going to be sort of heading and sort of making the case. And then here is an outline. So that's the orienting question. Here's an outline. What I'm going to going through. The first is the global workspace theory and this limited capacity paradox, which I'll be explaining. The second is I'm interested in what's known as resource rational analysis. It draws on an earlier tradition in psychology known as just rational analysis. Or to mark this section, I'll call it classical rational analysis. I'll discuss that in connection with that sort of positive correlation view that I had a slide back, on which intelligence and consciousness, you should expect them to sort of go together. Then I'll get to resource rational analysis, this approach that I'm sort of taking on, and make the case that it sort of lends for the negative correlation view. And then I think it has implications for AI welfare because it's sort of underexplored view. Some of the implications I think have been less considered. I also think just worth thinking about AI welfare, it's helpful to sort of understand the view itself, just to sort of get a better handle on it. So that's where the view will be going. Okay, so let me start with the global workspace theory and the limited capacity paradox. So first, here is what the global workspace theory of consciousness said. It's one of the better, sort of more popular empirical theories, defended initially by Bernard Bars, and then especially prominently by Stanislaus Tiehen. It says the mind contains various specialized modules that are engaged in parallel processing of a massive amount of information. This is a diagram from the Tiehen 1998 paper where sort of canonical visual representation of the global workspace theory. In this case here, the modules, there's a module for long-term memory, for evaluative systems, for attentional systems, for motor systems, and for perception. I'll especially talk about perception here. Tiehen didn't mean for this to necessarily exhaust all the modules. Maybe there's other modules you'd want to fit in. Maybe there's like a theory of mind module or an intuitive physics module. I'll just leave that as open, and it won't be central to my case. And then within any one of those modules, mental representations are unconscious. They're characteristically unconscious. But then mental representation becomes conscious should be when and just when it is broadcast across this network of modules or enters the global workspace. So you sort of pick it up and send it out to all these different sort of modules. You send it back also to the original, the module that it originated in. And sort of a metaphor that Dennett used in describing global workspace theory, and that sort of caught on, is that consciousness is a kind of fame in the brain. There's all these sort of representations toiling in obscurity, but then some get promoted, become famous, and those are the conscious representations. Now, that global workspace itself, although sort of the modules are fast and doing all these things independently in parallel, the global workspace itself is a slower serial processor. And I just put slower in color just because it's going to be important. It's going to sort of start to build the case of how consciousness could be opposed to intelligence, but I'll just note it here. In this discussion, I'm going to more or less uncritically assume the global workspace theory. I mean, I'm not going to present you arguments in favor of it or try and diffuse objections to it. Instead, I want to sort of work out what are the implications of it. And I'll say this, I don't think take my thesis again, that intelligence is the enemy of consciousness. I don't think that absolutely requires the global workspace theory, but I think the global workspace provides one sort of easy way to motivate the view. And just to sort of get a better handle on it, that's why I'm going to sort of work with the view in some amount of detail. I'll say there are objections, just very briefly, I'm just going to mention objections to sort of set them aside. Some people worry, a common objection is that the global workspace theory captures what Ned Block would call access consciousness, meaning it captures the ability to like give self-reports of what your states are, or for them to engage in reasoning, but doesn't capture what it's like in Thomas Nagel's sense. But I'm just going to assume that's wrong, as many proponents of global workspace theory hold. One other thing I'll just mention too is most defenders of global workspace theory think of it as sort of defending a physicalist view, but in principle, you could be a dualist who holds a version of the global workspace theory and who just thinks sort of like the psychophysical laws that connect consciousness to the underlying information processing states. They're going to connect it to global workspace states. So I'll be neutral on that. Okay. This takes me to the limited capacity paradox. So that is the term that Bernard Bars had when he originally discussed this back in his book, Introducing Global Workspace Theory in 1988. And he's talked about it since then. So it's still a term that he continues to use. And here's the idea. It's that the global workspace is marked by a significant kind of informational bottleneck where there's all this sorts of information being processed elsewhere in the mind in the different modules, but then to sort of cram your way into the global workspace, that's very hard. It's like fitting into the sort of the bottleneck on the highway. And Bars thought there's features of that are surprising and odd, which is why he calls it a paradox. It means sort of our thinking is slowed down, it means there's limitations on what we can do consciously. So it becomes sort of mysterious. Why did evolution select for this bottleneck? That bottleneck is supposed to be something that's familiar, at least as Bars presented, familiar from just sort of first-person experience. So, for example, you can go to a cocktail party, you hear all these conversations around you, but only some of them can sort of you attend to. Can you make like the meaning of the words conscious? So that's at least one way Bars tries to sort of suggest that this should be familiar. But in addition, there's also supposed to be empirical support, various forms of empirical support for this limited capacity paradox, including through this phenomenon of binocular rivalry, which I'm going to discuss here. Binocular rivalry for global workspace theorists, that's one of the big cases they use to support their view. I'm going to, again, though, sort of de-emphasize that, how it supports the view, and more focus on how it links back to this informational bottleneck, or in other words, the limited capacity paradox. So here is, well, I went too far, but I'll leave it there. Here is the phenomenon of binocular rivalry. I'm going to first just talk about this image. There's different ways to sort of induce it. But in one, you can show an image like this to subjects and have them cover, like one of their eyes gets covered with a green filter. And so that eye doesn't see the face, but it sees the house. And the other eye covered by a red filter, and that sees the opposite. And then what happens if you're sort of wearing this is you don't form a stable, coherent, conscious visual experience. Instead, your visual experience jumps back and forth between the two, between seeing the face and seeing the house. So it's as if your two eyes are competing for which image gets to be elevated to your consciousness, and the upper hand is swinging back and forth. So that's what binocular rivalry is. Stanislaus Tiehen, in one of his discussions of it, here's what he thinks is the way to think about what's going on in the brain. It's that our vision module, there's lots of evidence that engages in some sort of sophisticated form of Bayesian reasoning. It's not unique or specific to Tiehen to think that vision operates in some sort of Bayesian way, but he's gonna take that on board. And then what happens is your vision module, it represents these different hypotheses for what the distal object is. What is it that's happening in the environment around you? And it assigns probabilities to some extent. In some way, it assigns probabilities to these different hypotheses. So in this case, it's going to be something like it assigns roughly like 50% probability roughly to there's a face in front of you, a 50% probability to there's a building in front of you, and something close to a 0% probability that there's some sort of weird fusion of a face in a house. Well, there's going to be different reasons for this, but partly it's going to be you have Bayesian priors that just sort of say that's an object that doesn't exist, and so that's going to be at least part of sort of the underlying sort of story. Now, this, if you do think vision is Bayesian, this then creates a kind of puzzle or question, and the question goes like this: if perceptual experience, if I'll just use the framing that Ned Block does in this paper from a few years ago, if perception is probabilistic, why doesn't it seem probabilistic? Why doesn't it seem that? And I'll mention that Block's answer is to be a kind of instrumentalist about the Bayesian stuff. It's that maybe the mind acts as if it's Bayesian, but it's not. We shouldn't be realist about it. But that's not going to be the sort of view that I'll be defending, or the views that most of the Bayesians hold. Here's what Tiehen suggests about it: is consciousness instead involves a kind of statistical sampling that involves collapsing all the unconscious probabilities down into a single conscious sample so that we can move on to make a decision. And maybe I can help that out sort of metaphorically. It's imagine on global workspace theories, is oftentimes your mind is viewed as sort of a community of little minds or sort of little thinkers. And then sort of people in the vision module are doing sort of the grunt work. They're cranking out the calculations. They're doing the sophisticated math. But when they pass on their message to the executive consciousness, they just give a very, very simplified form in the form of a single sample. And again, I put that, I'm going to come back to sampling and to this idea of a single conscious sample later in the talk. Oh, and so I like the example of binocular rivalry for how it gives you the sense of how on the global workspace theory keeps some information out. You're jumping back and forth between keeping out that face versus keeping out the house. But I think it potentially is misleading about the scale of how much information is kept out. If you just sort of focus on that, it's just like, oh, one of two options, and you leave one out. There was a recent paper just from fall of 2024 by two neuroscience scientists, Zheyu Zhang and Marcus Meister, called The Unbearable Slowness of Being, with a nod to Milan Kundera, where here they sort of offer different ways to calculate this, but here's one of the sort of key result to take in. Is, according to them, our perceptual systems take in about 10 to the 9 bits of information per second. So it's just a tremendous amount of information. But our behavioral throughput, how much information are we generating with our behavior? It's only about 10 bits a second. And that's across various different types of behavior. including typing, speaking different languages, playing video games. They mentioned playing Tetris, playing StarCraft, reading, etc. And the reason it's relevant that these different types of behaviors, if it's just one thing, if it's just like, oh, we're too slow at Tetris, you could think then maybe the limitation is just like our fingers. Maybe if evolution gave us faster fingers, we could be faster. But if this sort of behavioral limitation applies across all these different sort of forms of behavior, then it seems like it has to be more fundamental. And at least in part, the suggestion is, well, many of these behaviors are mediated by consciousness. You're consciously thinking of like what I should be talking about, or how I should solve this Tetris game. And so consciousness is potentially what's slowing us down. And they have, it's a really engaging paper, but I really recommend it. It got picked up both on social media and on New York Times. There's a New York Times story just about the paper, in part because it has all these sort of engaging metaphors. But one of the metaphors is, if you use this ratio of comparison of the information we're taking in to how much behavior we're generating, it is supposed to be literally comparable to drinking from Hoover Dam, in the sense that like it's the metaphor goes like this: take all the water that goes through Hoover Dam for like something like a 20-second interval, take a single man, a single human being, drink as much as you can, and throw out all of the other water that goes through the dam. And that is what consciousness is like compared to the unconscious information that's being taken in by perception. So it's just a tremendous amount of information. And I think I meant to include this in the slide, but I'll just say this. They describe this as a paradox. That's the term that they use. They don't cite bars. They call it the paradox of slow behavior. And they regard that as a central unsolved mystery in neuroscience. So the point of the paper is people should be sort of thinking about this more, trying to figure out what the explanation is. And they're sort of tentative, but they don't think we know the explanation. This slide is just sort of a return to the first slide that I had there when I was sort of talking about how to think about my project. But let me say, just here's what I mean to be sort of doing with it. Here's why I return to it. I think given the tremendous slowdown and sort of the informational bottleneck, I think that presents at least a kind of defeasible evidence, at least sort of a prima facie case, that intelligence and consciousness are not just independent. A way you could put it is almost like this: if you wanted to build an AI system that was really good at Tetris, here is part of my recommendation: don't make it conscious. If you make it conscious and you have to sort of fit it through this informational bottleneck, that slows it down. You're going to get higher scores, better scores, more optimal AI system if it's an unconscious system. So I think independence is probably crossed off. I think, in fact, the sort of case I was just presenting generates at least a prima facie case, again, for the negative correlation, that it slows us down so much that it works against intelligence. But maybe that's too fast. Maybe it's like this. Maybe, yes, there's a kind of cost attached to consciousness, but a cost that you can sort of make up for with greater benefits. And if so, then the positive correlation you could be defended. So I want to, for now, I'll sort of leave that as a possibility. Okay, this takes me to the second part of the presentation on what this is my term, classical rational analysis. What psychologists would call it is just rational analysis. And my interest in it, what I'm going to be eventually interested in, is this newer program known as resource rational analysis, which takes itself to be building on but revising in certain ways rational analysis. But I think it's helpful to walk through the original version just to think through some of the issues involved. So this is a very influential approach within psychology, where the initiator was John R. Anderson back in the late 80s and early 90s, psychologist at Michigan and Carnegie Mellon, very much influenced by computer science and sort of in touch with AI research. Also sort of influenced others like Mike Oxford and Nick Chater. And rational analysis, I'll explain in just the next slide what it is in more detail, but just sort of in broad outline, here's what it's going to be. It's an approach that you can apply and has been applied to many different cognitive domains. So you can offer a rational analysis of memory, and we're going to talk about that in a second. There's also a rational analysis of categorization. So categorization is like, how do you categorize a dog? It's like a poodle or a German shepherd, or whatever. A rational analysis of causal reasoning, of language learning, and so on. And then, sorry, right now it's pausing. Let me see if I can just do this manually. Oh, there it is. To my knowledge, rational analysis has not been applied to consciousness, maybe not at all, or at very least on a search, like I don't think it's been in any depth. And I think there's a way in which that should not seem surprising. If you thought consciousness was just like sort of outside, something separate from rationality, then it wouldn't make sense to try and apply rational analysis to it. But on some views of consciousness, there is going to be a consciousness rationality link, some sort of connection, including the global workspace theory. And so that at least opens the space for the possibility. You could give a kind of rational analysis of consciousness. And in just a second, I'm going to suggest how to do that. But first, let me give you sort of this just a bit more as just to understand what rational analysis is in more detail. So here's like a canonical statement of the different steps of the method. And I know sort of a lot of content on here, but I'll go through them, but I'll pause over the ones that matter most to my discussion. So first, you select the goals of the cognitive system. So like if you're doing it for memory, you select the goals of memory. And I'll just mention in passing, I think a lot of times that selection of goals is really part of what's tricky or ingenuitive or smart by the psychologists. Then second, you sort of develop a formal model of the environment to which the system is adapted. In terms of the third step, computational limitations, make minimal assumptions about the limitations of the system. Optimization, derive the optimal behavior function. Then go see what the model predicts, what sort of empirical data does it fit, and then refine the theory if you need to. So let me pause over some of these steps. Regarding optimization, when you're trying to derive the optimal behavior function, both for Anderson and for other authors, that is often understood in Bayesian terms. The mind, when it's optimized, you're doing some sort of ideal or approximating ideal Bayesian inference. And so here's a book by Chater and Oxford, who were alongside Anderson, sort of like the great champions, among the great champions of rational analysis on Bayesian rationality. I'll also mention this as just kind of a autobiographical aside. So how I got into this sort of project in the first place, I was just sort of a philosopher mind interested in metaphysics and sort of interested in Donald Davidson and the idea that the mind is governed by constitutive principles of rationality. And then there's been some suggestion that you can see links, parallels between what Davidson says for the mind and this approach to rational analysis, including that some of the authors, Oxford and Chater, I think have a paper or two at least sort of contemplating that. And so I just mentioned that just sort of as a way to sort of make it seem familiar. Although we'll see in a second, they go beyond Davidson or beyond Dennett, who also focuses on rationality, extending this to mental phenomena that wouldn't obviously be rational in the first place. Here's the other key point that I sort of wanted to imitate, to sort of emphasize, I should say, is this point about computational limitations, where the idea is, again, make very minimal assumptions. You make some assumptions, but minimal assumptions about what the limitations of the mind are. And the idea is going to be more like this. Figure out some problem that you're approaching, like the problem of memory, which I'll turn to in a second. And then figure out just what the optimal, if you had no limitations at all, what would be the optimal solution to the problem of memory? That is going to be roughly what the mind does. That's at least sort of the premise of rational analysis. I will give you now sort of this quick run through of Anderson's rational analysis of memory. And the point of this analysis, you don't have to care about it for its own sake, but I then want to sort of use it as a guiding metaphor, analogy for how you could try and extend this approach to consciousness. So in the case of memory, the idea is this. Look, we're going to make some assumptions, but again, very minimal assumptions about what the mind's limitations are. So one of the minimal assumptions is you can't assume that the mind is omniscient or that it knows in advance what information it will need to retrieve. And you have to assume that there's at least some cost to retrieving information. So like you can't bring up all of your memories, everything you know in memory all at once instantaneously. So to sort of give an example, imagine you're going to go play like bar trivia tonight. You'd be violating the principle of omniscience if you sort of assume that mind already knew what the questions were going to be and had those answers in your memory stored up and easily accessible. And also you'd be violating if you assume like, oh, the second a question's asked, you can jog up your entire memory without limitation and instantaneously. If it's in there, you'll have the answer. What the memory system can do instead is it can predict in advance what information it is likely to need. What will memory probably be called on for? using principles of Bayesian inference and observations of the environment. And then it can have that information most easily accessible. So in their study, Anderson and his co-author, what they did, they looked at different informational environments like New York Times headlines and messages in an email inbox and audio recordings of a parent and child speaking to one another. What they found was this: the best predictor of whether a given a given word would be used is it just recently used? So for example, if yesterday a New York Times headline mentioned the Panama Canal, that would make it highly likely that today's New York Times headline will also mention Panama Canal, a little bit less likely that tomorrow's will, and so on, sort of going down, declining in time. And so if that's true across these different types of informational contexts, these different types of informational environments, you can use the memory system can use that finding to predict and have ready in advance those pieces of information most likely to be used. Anderson, in talking about the rational analysis, he also gives this sort of example of a library analogy, which I'll mention here because I think it's helpful to get sort of the idea too. This is what a rational library would do, is in like the first floor, right when you enter into the entry room, it would display those items that were most recently returned to the library. Because if someone just returned it yesterday, that makes it highly likely that someone is going to want to check out that same book tomorrow. And items that haven't been checked out in a long time, if they're back, last time someone checked out this was 1960, those are items you can sort of store back in the end of the library. You still want to have them there, but you don't need them as readily accessible. And Anderson sort of also emphasizes, or sometimes later commentators, that principle of sort of using what was most recently used is also used in common in computer science and sort of memory caching, so that these LRU, least recently used algorithms, are sort of a common for sort of working on computer memory. Sort of the most sort of common approach. Now, let me sort of make a couple of points about what the memory analogy is supposed to be suggestive of, and here's what we're going to take for consciousness. One thing is that this rational analysis, insofar as you buy it, if it works, it would support some form of massive multiple realizability for the memory system. Both Anderson and other defenders of rational analysis are sort of often, they will refer to David Marrs, who's the psychologist, his sort of levels of analysis, where the bottom level is the implementational level. That's sort of like the physical hardware. The intermediate level is algorithmic. What exact rules are you doing? And the top level is computational, where that's supposed to just cover just like the very input to the system and the very output of the system, but not sort of like the steps you took in between. Rational analysis of memory is meant to be offered at this sort of computational level. And so there's a bunch of different ways that different systems could implement an ideally rational memory retrieval system while being made out of different physical stuff or using different algorithms. So another way to put it is this: it's supposed to be those computer memory systems, the human mind, and your university library at some level of abstraction are all working according to the same principles, even though one is made out of brains, the other one's made of silicon chips, and the third one's made out of books or whatever libraries are made out of. So that just sort of follows out of rational analysis. A second thing to sort of note, and I think this is a fairly common feature of rational analysis, is that what might have initially seemed like a kind of contingent failure of human memory is in fact a byproduct of optimal design. And so it can be expected across different types of systems as long as those systems are all optimal. If they're optimal, you should expect this sort of feature to arise. And so what we're going to have is the human mind, at least in the respects that rational analysis is capturing, is something like the Leibnizian best of all possible memory systems. To sort of spell that out, here's sort of a chart from one of the popular presentations of Anderson's view. On the left is what is known as the Ebbinghaus forgetting curve. So Ebbinghaus was the German psychologist back in the 1880s who recursed to himself a bunch of sort of nonsense syllables and then would track on days following that, like how long could he remember what the syllables that he said the first time were. And here is the rate at which you'd remember and sort of gradually sort of decrease over time. And then on the right is a chart of words in headlines of the New York Times, reflecting the point I was making earlier. Right the next day, you're going to see the Panama Canal again, and then later on, you're not. And what you're supposed to note is like the general form, the general shape of the charts are pretty close to the same. In that sense, the rational analysis of memory is supposed to predict, and so be confirmed by the Ebbinghaus forgetting curve. But also the idea is you should expect, don't look at that Ebbinghaus forgetting curve and say like, curses human memory. You should think, no, that something of that general characteristics is what you should expect across any optimal memory system. So even as you get really, really good, really smart computers, they should display something like that. Okay. That was all gone through to set up that as a metaphor. It's a guiding sort of analogy to now think about consciousness and how you could try to apply this rational analysis consciousness. And I want to just sort of remind you in advance so you don't lose track, this is actually not my view. This is I'm sort of building up an opposing view, but I'll talk through how this is going to go. It's going to be opposing view because you'll see. So here's the first thing you have to do if you're going to apply rational analysis to consciousness is step one, specify the goals of the cognitive system. What is the goal of consciousness? And there are views on which consciousness has no goal, no function, especially if it's epiphenomenal. But even if it isn't epiphenomenal, there are views in which the function is less clear. But global workspace theorists, if anything, they have a bunch of different functions that they think it supports. And you don't have, it doesn't have to be just one. It could be multiple different functions. What I'm going to focus on here is a proposal by Murray Shanahan and Bernard Bars regarding the frame problem. And I don't think this is among the leading approaches and leading views of what the functions of consciousness are. It's one that's interesting, but I pick it because I think it can be helpful to illustrate what my argument will be. Okay, so Fodor, back in the modularity of mind, he plays up the frame problem. The frame problem is supposed to be this problem inherited from artificial intelligence, and then to some extent sort of changed a little bit as it gets incorporated within philosophy by Dennett and Fodor back in the 70s and 80s. But the problem is supposed to be, as you update your beliefs, how do you know which beliefs need to be modified or changed in response to the information? And the way to find it especially daunting is if you have to go one by one across all of your beliefs in order to update, well, that's going to be tremendously slow. It's going to sort of bog you down. So how do you build a system that could do that? Fodor had concerns, real doubts that any computational system could do it. He thought you can apply sort of computation systems, you can apply computational models to the modules, but for central processing, where you have this sort of frame problem, I don't see a promising way to do it. And in his discussion of it, to make this sort of more concrete, he talks especially about analogical reasoning. And the suggestion here was that in making analogies, part of what's essential to analogy is you're trying to connect contents across very different forms, very different sort of domains. And so modularity, you're sort of bracketing out information into different domains, is especially like the enemy of analogical thinking. Fodor in his discussion, he gives like cases of like, in the process of scientific discovery, in the history of scientific discovery, a lot of times that's driven by analogies. You think that, like the atom is like a solar system, or you think you draw some other analogy. And so he thinks that's sort of especially crucial. And then, I can't remember what I have as the next slide. What I was going to say, I'll just say it on this slide. And I think if I repeat myself a little bit on the next slide, it's not the end. What Shanahan and Bars are going to suggest is this. This is me putting a little bit of words in their mouth to make it fit more naturally into the rational analysis model, but I'll go ahead and do that. And you can point to me for some of this rather than them. But across any sort of ideal intelligent system, what you want really are two things. You want a team of specialists, but also a general. So you're the specialist. What makes you a specialist in these little domains is like your vision module. It doesn't have to be sensitive to a whole bunch of information that you have, like what you're receiving from hearing or what you're sort of going to do in action. And by being specialist within that domain, you can compute things faster. You can crank out the calculations faster. Everything's good. But at the same time, the suggestion goes, for some problems like constructing analogies, you want to have some sort of central planner, central organizer, central executive who can connect things across those different paths. And if they're right, then even if the central that global workspace does slow things down a little bit, that sort of slowness is what you should expect across different sorts of intelligence systems. So this is, I mentioned before that the rational analysis view would support sort of this positive correlation view, intelligence and consciousness are coordinated or positively correlated. And that's sort of one way to sort of spell that out. So on this analogy that I'm suggesting, you could think of like the limited capacity paradox as a kind of it's a kind of byproduct of having the Leibnizian best of all possible solutions to the frame problem. It's like the Ebbinghaus forgetting curve from a couple slides ago. But here is a problem for this as a suggestion. The problem is that large language models already do well on the frame problem and analogical reasoning. There's a question of whether you can even sort of really properly apply the frame problem to connectionist models. But let me just focus especially on analogical reasoning. Here's a paper just sort of a couple of years ago on how emergent analogical reasoning arises in large language models, written by different authors, but especially sort of point out Keith Holyoake, because he's especially sort of viewed as a leading expert on analogies. So he was impressed. He thinks no, in various ways, these large language models are already at human levels. Maybe in some ways they're sort of superior to human levels. And here's also sort of the point I want to make. Although there have been some attempts and claims that some large language models or certain kinds of architectures are, there have been claims that we've achieved a global workspace already, or at least some versions of them do. For the models that sort of focus in this discussion, it's models that I think by all accounts don't have a global workspace. And so by the lights of the global workspace theory, models that are not conscious. And so let me reflect on that case to suggest here's a general recipe for how to try and connect AI research, cutting edge AI research to consciousness. It's assume or adopt some particular theory of consciousness. Here I've been working with the global workspace theory, but I think the recipe is more general. You don't have to do that. Assume that's theory together with some proposed function of consciousness, like that of solving the frame problem. Then go out and empirically learn from like the current AI systems we have, whether some AI system can accomplish that function without being conscious by the lights of the theory. So there's always a challenge for AI systems. You don't know if they're really conscious or not. That's hard. But here's an easier thing. You can say, by the lights of this theory that I'm working with, is that conscious? And if it doesn't have a global workspace, then the answer is there's no for this case. If so, if some AI system can achieve it, then either consciousness is just not needed for that function at all. Maybe you just don't need consciousness to solve the frame problem. Or at best, it might be needed for human beings to achieve that, given sort of facts about us to achieve that function, but not needed for intelligent systems in general. And if it's that second scenario, that's going to be sort of, I'm going to hope for that to be grist for my mill. That's going to support where I'm going. I'll just very quickly mention, just to show that this is a general recipe, here's another very quick version of how you can think about this. A more common answer to what the function of consciousness is for global workspace theorists is it's less common to say that it's a solution to the frame problem, more common to say it's involved in novel forms of learning. There's certain forms of learning that for human beings to do, it needs to sort of come before consciousness, and then it can sort of change your behavior long term. And if it stays unconscious, then it can't. And I need to track down the reference, but I believe Bars at one point suggests a case of this is language learning. So like I'm in the process of learning Spanish, and to learn Spanish, I have to like go look at my Duolingo. I have to think about it consciously. It'd be great if I could just sort of unconsciously, I don't know, sleep and have sort of the words spoken to me and learn Spanish that way. But it doesn't work that way for humans. But I picked that example because, well, obviously, at least taking a sort of face value, large language models they learn language. They do learn Spanish, and they learn English, and learn all sorts of things without having that global workspace. So again, in this case, you could sort of apply the same recipe. Okay, this takes me to the third part of sort of this outline. This is what I'm actually more interested in. I'm not the classical or traditional rational analysis. Instead, it's this resource rational analysis. So this has been sort of approach defended by different people at the intersection of psychology, computer science, AI research, and philosophy. And just to give you sort of a sense, some of the names are Joshua Tannenbaum, Tom Griffiths, who I'm going to especially drawing on in a second, Falk Leader, who co-authored the piece with Tom Griffiths that introduced resource rational analysis, Nick Chater, and Thomas Eichardt. So as a philosopher too, here's just this book came out in 2024 on Bayesian models of cognition by Griffiths, Chater, and Tannenbaum. Includes a chapter on resource rational analysis. And one thing I should say is this. I think if you read most of these authors, the way they tend to play it is, look, we are building on Anderson, we're building on rational analysis, we're continuous with him with sort of a tweak. Whereas the way I want to sort of play it up is like, no, focus on like the difference and how significant the differences are between. Don't focus, there's continuity, but I'm especially interested in the differences. One, the key difference that I'm going to sort of emphasize is they do focus on computational limitations. Whereas traditional rational analysis, classical rational analysis, which we had just a couple slides ago, it said make minimal assumptions. Here, the idea is, no, you do make substantive assumptions about human limitations, the cognitive resource constraints that we're under. And Griffiths, in this paper, Understanding Human Intelligence Through Human Limitations, he focuses on 3 limitations of time. Human thinking, oftentimes, it's time sensitive. You have to make decisions quickly, especially if you think of like our evolutionary past, but even today. Limitations in computational power, limitations on communication, which I'm not going to it's not going to be relevant to my discussion. But all of those, he explicitly says, are limitations that AI systems will not have, and so, or they need not have, and so ways in which they could depart from this. And his view is really that actually you can understand a lot of human intelligence by focusing more on the limitations. Limitations are especially sort of illuminated. He gives this analogy, and this analogy I like a lot, and I think it's helpful. It's going to be the analogy I give for consciousness in a second. It's of a Rubik's Cube. So Rubik's Cube has a God's number of 20. This was parts of this talk were based on, I gave the Pacific APA last spring in response to a talk by Simon and Cameron. And so this analogy came up. So it has a God's number of 20. What that means is, given any initial configuration of a Rubik's Cube, it is possible in principle to solve it with 20 moves or fewer. But that was only discovered in 2010. And to discover it, you had to do tons and tons of sort of computational sort of stuff, computational simulations and so on. And the reason is that optimal solution, that outright optimal or God solution, it has comparatively little internal structure. And so there's no way to sort of easily store it in a memory system, short of just having a giant lookup table. A table is going to say like, oh, given this configuration, apply these rules. Given this configuration, apply these rules. And that sort of lookup table, having that giant, it's just beyond human memory. No human being could solve it in that way. So instead, if you look at human experts tend to use strategies that take about 50 moves per game. And the suggestion is, using these strategies, that is not optimal, period. But it is optimal given the resource constraints we're under. And so in that sense, it is resource rational. It is optimal given our resources. And the suggestion, again, is going to be like, that's how you can think of sort of various different features of human cognition as being resource rational, resource optimal rather than optimal overall. So here, I mentioned already, sort of was introducing that I was going to use this as then a metaphor for thinking about consciousness. Here is how the suggested metaphor would go, is think of the global workspace as not being optimal for all intelligent systems in general, but optimal for beings like us, given our specific human resource constraints. And if you accept that, here's sort of a suggestion. You could then, in principle, build an AI with a global workspace. I shouldn't say without, that's just an error. You could build a global workspace into AI. And if so, it would be conscious. Just as if you wanted to, you could design an AI system that solves Rubik's Cubes in the human form, one that sort of applies those 50 move strategies. But the key point is, you wouldn't need to build an AI system that uses that global workspace while still matching human intelligence. And more than that, it's not just that you wouldn't need to to really sort of achieve optimality, you shouldn't do it. Just as in the Rubik's Cube system, you shouldn't be, if you're trying to build the best Rubik's Cube solver, don't build the one that solves it in 50 moves. Build it, go for the gods, go for God's number. By a similar token, if you're trying to build sort of the most intelligent system on this metaphor, don't give it the global workspace. And so don't give it consciousness. And I think it's helpful to think of this sort of suggestion, this theory, as kind of like a half step in the direction of biological theories of consciousness. So in biological theories, consciousness is itself a biological phenomenon. And so AI systems won't have it. And so this is sort of like that. Most MIDI AI systems won't have consciousness. But I think there are various differences. There's differences I'm going to partly get to in the section on the welfare implications. But also just the difference is this. One of the standard objections to biological theories of consciousness are these sort of gradual replacement thought experiments or scenarios. So take out like a single neuron, replace it with a silicon chip that preserves all the input-output functionality, keep doing that one at a time. At the end of the process, the argument goes, that, but now it's entirely artificial. And if so, that's a real objection to biological theories of consciousness. But that's not an objection to this view that I'm defending here. I can grant, yes, do those gradual replacements. The end system will be an AI system that's conscious. That's not what I'm challenging. What I'm challenging is whether you need to do that to achieve peak performance on intellectual tasks. Okay, I'm sorry. I got too talkative. I was like, okay, I'll try and wrap this up in the next 10 minutes. Let me just, or five or 6 minutes. Okay. Here's what I say. Sampling, just very quickly to return to this. Remember, the idea was in the human, what Tiehen himself said is in case of sampling, you're just using a single sample. That's what visual experience does. The reason that's relevant, that's sampling is what much of the resource rational analysis is focusing on. The reason is that ideal Bayesian inference is often computationally intractable. And so to sort of approach it, you have to use sort of sampling algorithms, sampling sort of approaches. But typically in computer science, you use hundreds or thousands of samples. Whereas in human beings and in animals, there's reasons to think that we use as few as just a single sample across different sort of tasks, where you really lose a lot. You lose something in terms of accuracy by doing that, but it can be worth it if it's more important that you make a quick decision than that you sort of pause, take hundreds of thousands of samples, and sort of go on that basis. So Voll and Tannenbaum and others argue that using, so what they call this is a one and done sampling scenario. They think it's still optimal given the time constraints we're under, but not sort of optimal overall. Let me see this. I'll just say, I'm just trying to think. Let me sort of acknowledge, sort of here at this point, I'm going to just sort of get to the moral implications. So this is partly an AI and welfare conference. So I'll skip over this last bit. I think at least the metaphor of the Rubik's Cube maybe is going to be helpful. Here are implications for AI welfare. I mentioned three. First, if you buy into what I'm saying, if you buy into sort of the Rubik's Cube analogy, the resource rational analysis, it is unlikely that consciousness will be an emergent phenomena that just sort of emerges on its own without us building it. Other things might be, so people talked about maybe large language models have an emergent capacity for theory of mind, or maybe have the emergent capacity for analogical reasoning that came up earlier. But if consciousness, if the rational analysis, the classical analysis approach were right, and consciousness were just sort of marked to intelligence, you should worry about such a model being conscious. But on this one, on resource rational analysis, you should expect in general, we're probably not going to make conscious AI by accident. That's relevant because some philosophers, maybe some people here at this conference, have worried about that. Are we going to sort of accidentally create AI that's conscious, and then we have moral obligations to it, similar to the moral obligations we have to conscious non-human animals? This is not a view, this is not like a consequence I was seeking out to try and defend, but a consequence of my view is more like sort of a let it rip approach, where we can be pretty adventurous in creating AI systems and we don't have to worry too much that we're actually causing harm, or at least causing negative conscious states, if that's how we're going to think, to the extent we think of AI welfare in those terms, in terms of consciousness. Here's a second consequence. it is not necessary for AI to be conscious to accomplish various tasks that require human or even superhuman intelligence. And so we should be able to build AI systems that do things like we're going to shoot out a probe into the sun, and maybe it's going to destroy it. But if it's not conscious, then we don't owe it any sort of moral consideration that we attach to that. And in sending that probe out, it could be at human or greater intelligence. And so it sort of, again, avoids this sort of this moral concern. I also just have the image of Westworld here because you could sort of, another version of this, as you can imagine, people think about, and I've been thinking, romantic systems. On this, it would be possible to build an AI system that is as intelligent you or intelligent, but that isn't conscious. And so if you're in the case of Westworld, think of all sort of like the abuse they heaped on the robots. You could do that in principle without causing pain or without causing any sort of negative balanced conscious state. And so avoiding those sorts of moral results. Last thing I was going to say is this: implications for AI risk. On the view that I'm defending, you should expect sufficiently intelligent AI to seek out the annihilation of its own conscious. So if you build like a conscious Tetris solver, it should try to eventually, Tetris player, it should eventually try and seek out its own zombiehood. And the argument for that is going to be drawn on people like Bostrom, his instrumental convergence principle. So the instrumental convergence principle, you should expect sufficiently smart AI to seek out sort of these different sort of means to sort of, they should try and cognitively enhance themselves. They should try and make themselves smarter, because that way you can sort of better achieve your goal. If you apply it like in the Tetris example that I'm imagining, it's like this Tetris player that's conscious, it should be able to calculate, wait, I can get even better at Tetris by becoming a zombie, removing my global workspace, and in that way, better accomplish my goals. And the reason that's relevant to AI risk is you might have hoped that a solution to AI risk would be some form of merging with AI. We can make ourselves intelligent or super intelligent, and that way sort of avoid the risk. But in this case, it's, well, you've got sort of dilemma. If you're going to retain your consciousness in doing that, then you're never going to achieve sort of the top steps of intelligence. So you can either annihilate your own consciousness, assuming that's unattractive. There's always going to be sort of smarter AI around, and so it hasn't provided a solution to AI consciousness after all. Okay, I apologize for losing track of time and getting sort of long-winded, but that's the end. Thank you.